All right, so we are going to get started in graphs of proportional relationships. Now, graphs of proportional relationships is going to be found in Unit 5, Section 5. So you can write 5.5 here. We have already talked about what is a proportion, um, how is it proportional. We've identified them. We have found different methods on how we can solve them. And now you're going to learn how to graph. So your learning intention is to represent proportional relationships using graphs and equations. You will know that you are successful when you can determine whether quantities are proportional using a graph. You can find the unit rate of a proportional relationship using the graph, and you can create equations to represent proportional relationships. Okay, so some new things that you probably haven't heard before, so I need you to make sure you're focused, okay, because this could get a little confusing. So the first new thing we're going to talk about is the constant of proportionality. So what is the constant of proportionality? Well, it is when two quantities are in a directly proportional relationship, and the ratio of y and x is the constant of proportionality, k. So if I'm looking for the constant of proportionality, it is defined as this letter k. So AKA means also known as. So the constant of proportionality is also known as the slope or the rate of change. Okay. So to find the constant of proportionality, K, you will divide the y by x. Okay. So your equation will look K equals y divided by x. That's how I'm going to find the constant of proportionality. So K can only be found in proportional relationships. So if it's not proportional, you're not going to be able to find the K. So we're going to look first at what that means when we are looking at graphs. So in a proportional relationships, a straight line passes through the origin. And if you don't remember what that word origin means, it's the point at 0, 0. So if I'm looking at a graph, 0, 0 is right there in the middle of this cross section. It's before we move anywhere on the x or y axis. So this point right in the middle is going to be 0, 0, just like it states here. So when you're looking at graphs, if you see a straight line, and then you want to know, is this line proportional? What you're going to do is you're going to check, does it pass through the origin? Does it go through 0, 0? If it does, then yes, it is proportional. If it does not, then it is not proportional. Okay, so this side is proportional. So we know it's a straight line. So that's one, check. And it passes through the origin. There is a dot there on the 0, 0 because it passes directly through that origin. So I do know it is proportional. Now, how am I going to find K? To find K, I am going to find my points. So first, I'm going to go up like this because this is on the y-axis. Let's see how far I have to go to get here. So 1, 2, 3. So 3 would be y. So let's see, let's write it like this. Y equals 3. And then from here, I'm going to go 1, 2. That gets me to my dot. So 2 is x. So x equals 2. So therefore, my k, or my constant of proportionality, is 3 over 2. And remember, k is the slope. So when I'm looking for the slope of a line, I know that I'm going to just take my points y and x and figure out where that's at, and that's going to be my slope. So also known as the constant of proportionality. So let's look at this side. Non-proportional. So I've already told you it's not proportional, but let's find out why. Let's look at this graph. Well, I know first it has to be a straight line. Well, this one is a straight line, so it passes that. But then it says it has to pass through the origin. And remember, the origin is 0, 0. So that's going to be right here at this spot right in the middle. And does my line pass through that? No, it does not. And because it does not, it is non-proportional. So I don't have to figure anything else out. I can't tell what the K is because there is no way to find that out. Okay. So not, why is it not proportional? Because it is not through origin. Okay. So that's how you would figure out if a line on a graph is proportional or not. So now let's see if we can figure out it, when we're looking at tables, if they're proportional or not. We've started to look at this when we were looking at tables in the last couple sections. So let's just do a little review. So the ratio of y to x is constant for every value after you simplify. Okay, so this side is proportional. And I'm looking at x is 8, y is 2, but I have to, it says the ratio of y to x. So remember, y to x. But if I'm writing it as a proportion, I'm going to write it as a fraction in fraction form. So I'm going to write it as 2/8. Then I'm going to write this one as 5/20. And then I'm going to write this one as 7/28. But these can be simplified down, right? So as long as the constant for every value after you simplify is the same, then you know it's proportional. Because right now it doesn't look proportional. But if I simplify, 2/8 simplifies down to what? How many twos can go into 2? 1. How many twos go into 8? 4. Okay. How many fives go into 5? 1. How many fives go into 20? 4. How many sevens go into 7? 1. How many sevens go into 28? 4. Now what do I have? Look at this. My constant of proportionality is 1/4, 1/4, 1/4. So they are all the same after I simplified them down. So they are proportional. Now I'm going to look at this side. Non-proportional. So I've already given you the answer. It's not proportional, but let's see if we can figure out why. And I just realized that I didn't change these numbers. So I'll change this for you guys, but for the sake of this video, let me change it really quick. So this is going to be a 5 and a 3, 3 and 2. So we've already said that this is going to be 2/8. So this one will be 3/5, and this will be 2/3. Sorry, that's kind of hard to see. So 2/8 simplifies down to 1/4, and then 3/5. Well, 3/5 doesn't simplify down any further, right? And 2/3 doesn't simplify down any further either. So what does this tell us? 1/4, 3/5, 2/3, they're not simplified down the same. So they are not proportional because y divided by x is not constant. They're not constant. That means it doesn't continually increase at the same rate. Okay? Y divided by x is not constant. So let's look at this last one. This is all stuff that you guys have already talked about, so that shouldn't be too challenging. So let's look at what the equation portion of it, which also you should be a little bit comfortable with. So equations can be written in the format of y equals kx, or k times x. K is the constant of proportionality. The y-intercept is 0. Okay, so the y-intercept must be 0. So let's look at this one. So we have y equals 8x. So it is written in the format y equals k times x. So this one would be proportional. And just so we are aware, k equals 8. Okay, so then we have 3y equals 9x. Well, it has to be written as y by itself equals kx. So first I have to get rid of the 3 to get y by itself. So this is going to become y equals 3x. And then here is my k. K equals 3. So these both can be simplified down. This one was simplified. This one was already in the format it needed to be. This one was simplified down and was able to go to y equals k times x and k equals 3. So let's look at this side. These are not proportional. And here's why this one's not proportional. Because this problem, if I had it just like this, which looks like that one, right, it would be proportional because y equals k times x. But now that I'm adding this plus 10, this is a non-zero y-intercept because y-intercept is this number right here, which I don't know if you guys have learned much about that in sixth grade. But this number right here is called the y-intercept. And we don't want to have a y-intercept in a proportional relationship. Okay, so because this number sits here, this is a non-zero y-intercept. Okay, and then this one, y minus 9 plus, that should say equals, man, just making lots of mistakes today. Y minus 9 equals 18x. So I need to get y by itself. So I'm going to add 9 to both sides. So this will become y equals 18x plus 9. And what just happened? We added a y-intercept that was greater than 0. So this is not proportional because there is a non-zero y-intercept. Okay, so that's our y. It has to be written in this format or it can be simplified down to go to that format. If it doesn't, then the equation is not proportional. So let's flip this over and see if we can figure out what's going on the other side. So I've got a couple different things for you to try, but first I want to talk to you about this one. So in a proportional relationship, the unit rate, so you remember we talked about unit rate. Unit rate is if I have, say I have a ratio of 10 to 2. The unit rate would be 10 divided by 2. So in a proportional relationship, the unit rate is the constant of proportionality. K between the two variable quantities. Okay, so the unit rate is the constant of proportionality between those two variable quantities. So that means K equals Y divided by X. So here's what we're going to do. I want you to sketch a graph of a proportional relationship. So you can choose whatever your graph's going to look like. But remember, proportional relationships, two key things. It has to be a straight line and it has to go through the origin, which is the 0, 0. And then you're going to sketch a graph of a non-proportional relationship. So technically doesn't have to be straight because it's not proportional, right? That's not one of the qualifications, and it can't go through the origin. Over here, I want you to find K. So I want you to find our constant of proportionality. Remember, it has to look like when we are looking at an equation, it looks like y equals k times x. So that's what you're trying to get this to look like. So you're going to need to divide by 20 to get y by itself. And then what happens to, so then we have y equals, something happens over here, then tell me what k is going to be. Right here, this is asking, are x and y in a proportional relationship? Explain. So first, to find out if it's in a proportional relationship, I need to simplify it to get y by itself and see if my formula comes out. Okay, so that's what you're going to do. You're going to simplify it down and see if x and y are in a proportional relationship. The last part that you're going to do in these notes is answer this story problem for me. So it says Mia was on a space mission when she landed on a strange planet. Here, time moved faster than on Earth. She quickly noticed that every day she spent on the planet made her age more quickly. Mia kept track of how long she was on the planet and how much older she got. The graph shows the relationship between the days Mia spends on the planet, X, so that's this one, and the years that she ages, Y, going this way. So the first question is, what does 4 4 represents? So 4, this is the X, and this is your Y. So you need to go to 4 and 4. So what does this tell us? If I see this dot here, what is that telling me from the information I found on the graph? That's what you're going to tell me. And then you're going to calculate the unit rate or the constant of proportionality. And what does that represent? So you're going to take the, remember, constant of proportionality is K equals Y divided by X. So find one of our points and take Y, which is 2, divide it by X, which in this case is 2. So find out what is our unit rate or our constant of proportionality and what does that represent? What does that mean? So if our unit rate is, say it was 2, it's not, but say, what does that mean? Okay, and then the last one, given that the days on the planet X and the years aged Y have a proportional relationship, you're going to write an equation between X and Y. So that means you're going to take the answer you get for K from this problem, and you're going to write Y equals that number times X. So fill in your constant of proportionality right there. Okay, any questions that you have? I know that this can be a little bit of a confusing one. So if you have questions, make sure you come